Welcome to the seventh class of Financial Econometrics. I'm recording this in our computer lab that we're going to use once the face-to-face class resumes. I don't know when that is going to be. As you are aware of, the online lecture is extended until the fourth week of the semester. So quite likely this is going to be extended for the entire semester. But let's hope that that's not going to happen. I am here in front of the classroom, and the guy who is holding the camera is my beloved TA Sun Jetong. I thank him for being here and spending time helping take care of the camera. First thing first, plan for this lecture is as follows. So we are going to take a look at the main reading that we used in the previous class, which is the chapter 4 of Sullivan 2012, relation between two variables. Then the keywords are as follows. So section 2.1, correlation test. So here is where we were finishing last time. So today we are going to continue with the correlation test. And I remark that we would find some interesting examples related to finance as follows. So on question 38 is 4.1, then you are going to find applications about portfolio diversification, and on exercise 31, you are going to find an application to finance about CEO salary and stock return. Then exercises for section 4.2 are 7, 18, 25. For 4.3, we are going to practice at least exercise 6 together. So this week we are dealing with something really basic still, but these are very important for you to understand. Of course, the software that we are going to use would be Excel as well as this one here. If you have installed properly, you will find Excel Stat 2020 that I asked you to download and install. And if you have installed properly and open it properly, you would find that in your Excel sheet, the right tab, on the extreme right, you would get the Excel Stat module here, and then once you open it, then you would find quite some commands that you are going to be able to use. Clear to you? Next, outline not just for this lecture but also for the next lecture. We are going to get into the details of what we call least square method. I have taught this in operations management class, but it's important that you get to understand this one more time as the basic, plus not all students have taken the operation and production management class yet. So I need to repeat this, and then we would dig deeper into something new, and it's a little bit more complicated, which is to study about the diagnosis of the least square method. So LSM. usually stands for least square in econometrics. So if you see the word LS, usually it means least square method. And I'll come back to explain to you later on what I mean by least square here. And then I have here, this is pronounced homoskedasticity. It's a Greek word. Homoskedasticity is a very important keyword in econometrics. / heteroskedasticity. Let me reiterate. Heteroskedasticity. Okay? Homo means same. So homoskedasticity means constant error variance. Soon I'll come back to explain to you what it is. And of course, heteroskedasticity means, although I did not write it, allow me to write it here. Heteroskedasticity means, of course, non-constant error variance. Now, when we use the LS least square method, what we prefer is to have this one. Later on, of course, I'll explain to you why. Yeah, but I can tell you that this is good. Homoskedasticity, generally speaking, this is what we want to have. This one is not desirable. If you have heteroskedasticity in your least square analysis, it implies that your predicting power might be reduced. Next keyword, residual analysis. Residual analysis. Outlier. Influential observation. Good? So let's come back to this one. Section 4.1 that we were trying to complete last time. Let's see the two exercises, 31 and 38. Before I go to that though, let's just recall our memory as to what the correlation test is. Yeah? So correlation test here is like a hypothesis testing in statistics. So you have null hypothesis and then you have the so-called alternative hypothesis. So null hypothesis says no linear relationship between two variables of our interest. Alternative hypothesis means there is linear relationship between two variables. Yeah? So when we do this test, then we say that if we reject the null hypothesis, then we conclude that there is a linear relationship. Good? And that is why in this exercise that we were doing, which correspond to our reading here. So let me just remind you as to where the reading is. This is as shown here. On page 197. Clear? page 197. See here, determine whether a linear relation exists between two variables. All right? So it's a test, which we call correlation test. And we were practicing this exercise. Let me just recall your memory. Remember that I was mentioning about exercise 26, credit score. So FICO, this is exercise 26. FICO credit score indicates your financial reliability. The higher is the score, the more likely you're able to return the money if you borrow money from the bank. All right? So FICO score in the US is calculated using your salary, job stability that you have, as well as credit card history. Have you properly paid the credit card in the past, etc. And usually banks will use the credit score here in order to offer the interest rate. Note that if your credit score is low, then you would need to be borrowing at a higher rate because the bank consider you as a high-risk person. Conversely, if the credit score of yours is high, then you have that the interest rate that you would be able to borrow is low. So we were solving this one, and the way we solve it, is to see here. This is the Excel sheet, data sheet. Before I proceed, let me remind you that all these readings are downloadable in CTL. Recall that you need to go to CTL, then click the class Financial Econometrics, then click PDS. I'm not going to show you this one more time because I have done this so many times. PDS, yeah? If you have a problem, contact me or my TA. All right, good. So we were here, and the technique that we are going to use in Excel stat in order to do the correlation test is kind of straightforward, yeah? So the data file here, see the number here, these are converted into Excel data like this, yeah? As I did not put on the label, I'll put on the label here. So this is our credit score, and then here I have the interest rate, okay? So if you are watching this video, then my suggestion is to follow what I am doing. Just open an Excel sheet and try to do it along with me. And if you don't get it, then you can just pause the video and then do it again. All right? So you are here, and then you are going to click on, of course, Excel stat. Yeah? Once you are here, Excel stat, then here would be test a hypothesis. And we want this one, correlation test. Click here, correlation test. Observations. Then you are going to cover these two. All right? And then don't forget to mark your variables label. Yeah? This is very important. I remark that when you deal with real data, you have to be very meticulous. Why? Because variable label, suppose I remove it. What do you think is going to happen? What do you think is going to happen if I remove the box here, variable label? What would turn out is that it does not understand. Why? Because if I remove it, these two labels are considered as data. All right? So this becomes problematic. Excel that will not understand this, or if I just cover this one, yeah, know that I have 1, 2, 3, 4, 5, 6. I have 6 observations, right? Now, if I remove the label and then I click here, correlation test, and then I mark here variable labels, then what happened? Let's see. If I do this, weird thing would happen. Why? Because it would get to understand that that this one here and this one here, sorry, these two are the labels, right? And then the rest are the data. So you would have only 5 observations in this case. In conclusion, what you have to do, yeah, is to, of course, click on his hypothesis, then correlation test, cover everything here, click on variable labels, click OK. Make sure, by the way, that you click on the tab charts and you have the scatter plot with you as well. So if you do it properly, then you would be able to do the correlation test, yeah. And here, as I told you in the previous class, yeah, if the result here, see, 0.975, which is a -1, if these are in bold font, as stated here, then it means that you are able to reject this one in favor of this one. Clear? You're going to be reject this one in favor of this one. Alright? Now, as a reminder, what would be a situation in which you are not going to have such a bold font? Why don't we try this way? The interest rate, I'll set this to be 0, 0, 0, 0, 0, 0. So obviously there is no correlation between the credit score and the interest rate, right? Regardless of the credit score, the interest rate is always 0. So what we expect is that there is no linear relation. Indeed, there is no relation between the two variables. So if you try to run a correlation test, then you will find out that there is that nothing appears even. You see? Nothing at all appears. Right? Why? Because it's not significant. Clear? Which means that there is no linear relation. Or I could do this one more time. Let me just change the number to 1 one time, like this. And if I do this, of course, then I would find out that, see here, is near 0. The correlation is near 0, and it's not in bold font, which means that not different from 0, right? If it's bold, then it's different from 0. If it's not bold, then it's not different from 0, right? So in this case, you know that you are here. No linear relationship exists between two variables. Got it? Yeah? Next. Keep in mind that you don't need this number. These numbers on the diagonal axis, these are like 1, 1, 1, 1, 1, 1, 1, 1. Yeah? Reason is very simple, because this is the correlation between x variable and x variable. You see? Y variable and y variable. So the correlation has to be 1 because the two variables are identical. Clear? You don't need this one. You need this one here. Good? And in this case, the scatter plot would show cases that, see here, that there is almost no relation between the two variables. Alright? Good? Okay. So if you are clear with what I have taught in the previous class, then we can proceed to a new example, which is this one here, CEO performance. Yeah. So this is an application of correlation test to finance. All right. Now, what are we observing here? First of all, the question says that we select randomly 10 CEOs, and the company's stock performance in the year 2009. Okay? So here you have CEO salary and then stock return. All right? Why is this interesting to study? Because in the US in particular, and in the Western world, but more in the US, and to a lesser extent in Europe, CEOs are highly paid. And one important argument is that CEOs are usually overly paid. They are being paid too much, considering their performance and their abilities. Okay? And another very important point that people tend to discuss is that when you pay a lot to the CEOs, and when you evaluate their performance only the time that they control the company, what happens is that they don't do things that are good for the long-term performance of the company, right? They do things that would look good right away for the company. Why? Because their salaries and their performance are being evaluated consistently, right? So they don't need to care about what's going to happen in the future to the company, which is not a good thing, of course. Yeah. Now, of our interest is the CEO salaries and then the performance of the stock. Okay. Why is this important? Of course, because the performance of the stock represents the benefit that the stockholder can have, right? Know that if it's a public company, people who own the companies are the stockholders, right? CEO is only being hired in order to work for the company, and that's it. Clear? So we wish that if the CEOs are paid higher, then the stock return should be higher. That's of course ideal from the point of view of the stockholder. If the more you pay to the CEO, the stock return does not improve, then why pay a lot to the CEO? It does not make sense, isn't it? Right? So here we have like those well-known company in the US that you tend to know. Of course, you have like McDonald's, you have Kraft Foods. It's kind of interesting, isn't it, that as a remark, the CEO of Kraft Foods is paid a lot more than CEO of Boeing and CEO of McDonald's. Yeah. Now let's take a look at this one. Do you believe that if you increase the salary of the CEO, then the stock would perform better? Let's take a look at the statistic. Before we proceed, though, let's try to answer the question. Which one, according to the question A, is the explanatory variable? Which variable is the X? The one that predicts the other one, which is the Y. Of course, the explanatory variable is the CEO salary. The higher you pay, it should be influencing the return of the stock in a positive manner, not the opposite. Clear? Good. So let's do B, C, D and try to conclude if the stock performance here to play a role in determining the compensation of CEO, etc. All right? Is there a relation between the two? Let's see. Yeah. Now, how we are going to do it? Of course, this is very simple. Yeah. So what we want to do is to consider this data. See here. Just this data, and then we are going to use the correlation test. See? You need the data here, by the way. Exercise 31. So you're going to cover this one, and then let's find out what happens. What do you say here? Is this in bold font? No. If it's not in bold font, what does it mean? Not different from 0. Got it? So there is no linear relation between the CEO performance in terms of stock returns and the CEO salary. Alright? Yeah? So I remarked before I proceed that the issue on the studies about CEO performance is actually a very big studies in applied economics. All right, clear? Because it's not only how much you pay to the CEO, but also how you are going to evaluate his performance and how to motivate him to act for the base of the interest of the stockholder and the board member. Clear? Good. So no relation. You see here, if you take a look at this one, stock return and compensation, you see that actually though, if you take a look at the line, then generally speaking, you could say that there is even a negative relation. Yeah, the lower you pay, then the higher is the stock return, actually. All right, and you can see that there are a lot of weird cases like this. You see that the stock return is low, but the compensation of the CEO is very high. Okay. Conversely, there are weird cases like this too, where the stock return is very high, but the CEO salary is kind of low. Clear? Good? Yeah? Okay. Now let's proceed to another interesting example. And this one here is the exercise, my apology, not 38, 39. So allow me to just show you this one. Okay, this should look better. So this is question 39, kind of difficult to read. So let me zoom in. Let me just correct what I wrote here on the board. So this is not 38. I'll change this to 30. Alright, portfolio diversification. Now let's take a look at the question. Here, this is exercise 39 on the page 205. So let's read this together. Yeah, one basic theory of investing is diversification. Yeah, what do we mean? We mean that you want to have a basket of stocks that do not move in the same direction. You got it. You don't want the stocks to move in the same direction. Or if you think of this in terms of your business, yeah, if you have several businesses, yeah, say if you think of big companies like Samsung or Hyundai, they have business in several sectors, isn't it? This includes automobile and as well as electronic, construction, etc. Why do you think that they have several businesses? This is also for the sake of diversification, right? So at any given point of time, you could have that one business is good, but some other businesses are bad. Yeah, you don't want that all of them are bad. Why? Of course, if all of them are bad, then you would go bankrupt, right? What you wish is that some of them are good, but some of them are bad. Yeah, in this way you get a better diversification than moving in the same direction. All right, that's why it's written here that if one investment goes down, you don't want a second investment in your portfolio to go down as well. You don't want to see that. Yeah. Now, what would be an application if you use the correlation test? Of course, then what is undesirable? What is undesirable? One goes up and the other one goes up in the same direction, right? Tell me in that case, what is the characteristic of the correlation? Positive and close to 1. If it's equal to 1, then what happened? Then you have the perfect positive correlation, right? So one goes up, the other one is going to go up with the probability 1, right? You don't want that, keep in mind. Yeah. So if you want to avoid that, then there are two things that you can think about. Yeah. One is this one here, low correlation between investment. But what do we mean by low? There are two cases. One is that this one here, if you only wish to invest in 2 stocks, which one would you want to invest? If your goal is to have low correlation between 2 investments, okay? And moreover, which 2 would you select if your goal is to have one go up and the other one goes down? Do you understand the differences between the 2 questions? This one here, your goal is to have a low correlation, right? What does it mean, as low as possible? It means that you want that the 2 stocks return have the correlation that is as much as possible near 0. Clear? This one here, as much as possible near 0, as low as possible. So when the correlation is as low as possible, what do we mean? It means that they are not related to each other. You get it? You cannot say that one goes up, the other one goes up. You cannot say that one goes up, the other one goes down. You can never say that. They are just not related to each other. Okay? And this one here, one goes up, the other one goes down. It means what? You are looking for a negative correlation as much as possible. Yeah? Technically speaking, let me just write something that I taught in the Fundamentals of Finance class. If you have taken already, you would have seen this. If not, then you are going to see this in the second half of the semester. Yeah. So one thing to think about it is to consider. Let me see if I have the materials with me. Yeah. So allow me to just delete this one here. In order to explain to you. Alright, so this is for the question 31. Alright? So you can think of this way, yeah? If you have a 2-stock portfolio, okay? How do you measure the risk of your portfolio? So the risk of the portfolio is represented by the variance of the portfolio, sigma squared subscript p. I assume that you know this if you have taken fundamentals of finance already. All right? If not, then just be patient. We will see this in the second half of the semester. Then you would have this one here. Okay? Plus now notation. Of course, this is the variance, okay, of stock 1 and 2. You see? And then you would have here, of course, these are the weight, okay, on stock 1 and 2. All right? And an important variable here is this one. This is the correlation. Clear? This is the formula for the variance of the portfolio, which represents the risk of your portfolio. Right? So, of course, if you follow this formula, then what would happen if this one is equal to 1? If it's positive, the more positive is the correlation, the higher the risk will be, right? If this goes up, this goes up. See? Or if this one is negative, then it is good, isn't it? If this is negative, then you are reducing this one, right? Or if it's 0, then this whole term disappears, and you have that the variance is smaller than the case in which the correlation is positive. All right? 0 or negative correlation would yield the variance of the portfolio that is lower than the correlation that is positive, which leads to a higher variance of the portfolio. All right? So, to recap, there are 2 cases that we are interested in: as low correlation as possible, near 0, as stated in this question, or the other one would mean that we look for the correlation that is as much as possible negative. Good. So how are we going to be able to do this? Of course, then you need to go back to the data, but before that, why don't we take a look at the data a little bit? So here you have most of the well-known companies listed in Standard & Poor's 500. These are, for example, of course, Dell Computer. If you don't know Dell Computer, then you should not be taking this class, because the computer, every computer in this computer lab is actually a Dell computer. All right? Then you have General Electric, of course, you know, GE. And then you have, for example, ExxonMobil, which is an petroleum oil company. Clear? Good? Of course, needless to say, Walt Disney. Yeah? So, which one do you think have a low correlation, and which one do you think has the highest negative correlation? So our analysis would be to take a look at this one here, the data file. I have already converted the data here into number for you, so you need to use this one here. All right? So how are we going to do this? Of course, then we are going to cover everything, test a hypothesis, correlation. Then you are going to cover one more time. Okay. and then leave the rest as they are variables label, tick on this box, and chart, leave this available, then click OK, click continue. Voila, you are going to have a very big correlation matrix like this. Good. So let's see which one is nearest to 0. Which one is nearest to 0? Then you have that the lowest one is this one here, minus 0.044. This is nearest to 0 compared to the other ones. Okay, so Dell and ExxonMobil is the answer. Dell and ExxonMobil. If you are looking for a correlation that is very near to 0, all right. However, if you are looking for the most negative one, then you would find out that Dell and Teco Energy I highlight this in green. Dell and Teco Energy would have correlation that is the highest negative compared to other ones. All right, and if you take a look at the scatter plot, then it would be clear. All right, like for example, if you take a look at the Dell and Dell and ExxonMobil. Was it Dell and ExxonMobil? I don't remember. My apology. Yes, if you take a look at that of Dell and ExxonMobil, know that we have a lot of scattered diagram because of the fact that we have quite some stuff here. I'm sorry again. I'm not manipulating this properly. If you take a look at Dell and if you take a look at Dell and ExxonMobil, then obviously there is almost no correlation, isn't it? You see, the scatter plot is like all over the 4 quadrants, indicating that there is no correlation. Yeah. Of course, if you take a look at Dell and Teco, then you would find that this is a little bit better than the previous one, right? Overall, there seems to be a little bit of a negative correlation here. Yeah. So it goes like this. Why do you think when you consider like Dell and ExxonMobil, why do they have correlation that is near 0? This is nearest to 0 compared to other stocks and correlations. Why? It's very simple, of course, right? This is due to the fact that the 2 industries are very different from each other, isn't it? You expect that 2 stocks move together, usually, if they are in the same industry. The clearest case in point would be like tourism industry at this point of time. Yeah, if you purchase like 2 stocks of in the tourism industry, okay, I remark that a lot of well-known hotels that okay, around the world, yeah, JW, Marriott, etc. Yeah. Then a lot of these hotels are actually listed in the stock market. All right. So if you buy stocks of 2 hotels during this time, what do you expect? Of course, due to the coronavirus, both of them would move in the same direction, right? Which means that they're going to move down, right? If there is some good news about this, then of course they move up together. right? If the number of patients decline, for example. So this perhaps explain why, yeah, if I could give you a suggestion, it means that you should not buy more than one tourism stock if you want to begin to make an investment and take an opportunity of the fact that the stocks are getting cheap. Okay, don't buy like 2 or 3 stocks related to the same industry like tourism. I would not buy stocks of Boeing or like airplane companies and hotels at the same time unless I want to take risk. That would be another story, hoping that once the situation recovers, both of them would go up and then I would have a lot of return. Yeah. Of course, that would be different. But in any case, I think time is up for today. And then soon we proceed to what I listed here in the next lecture. Take care. Bye.